DreamXWorld is a general-purpose interactive world model. In this walkthrough, we take its open 5 billion parameter autoregressive model, get it running on a single consumer RTX for 4090, generate real examples, and share every fix and honest opinion along the way. Let's start with the concept. What exactly is an interactive world model, and what makes DreamXWorld different from an ordinary text-to-video generator? The idea is simple but powerful. You give the model a single still image and a short prompt. From that one frame, it imagines a coherent, three-dimensional world. Then you drive a virtual camera through it with simple keys, and the model generates a video of what you would see as you move. The picture stops being a flat image and becomes a place you can explore. Under the hood, there are 3 stages. First, a variational autoencoder compresses your image into a compact latent. Second, a diffusion transformer denoises new latent frames, guided by camera poses encoded as a projective transform. Third, the autoencoder decodes those latents back into pixels. Because it is autoregressive, it generates the video in small chunks, each one conditioned on the last, which is how it can roll forward over time. Controlling the camera feels like a video game. W pushes in, S pulls out, A and D strafe left and right. I and K tilt the view up and down, while J and L pan. Best of all, the actions compose. W plus K together pushes forward and tilts down to dive into a scene. Each action also takes a speed value that sets how aggressive the motion is. Theory is nice, but let's see it actually work. Every clip from here on was generated on the 4090 from a single input image in about 40 seconds each. First example. From a single still of a desert village, the action is forward. The camera dollies straight down the dirt street. Watch how the mud brick houses grow and slide past on both sides, and notice the model inventing brand new buildings further down the lane where were never in the original frame. Second example, a rock climber on a golden cliff. Here we use a composed action, WL, which moves forward while panning to the right. That single combined move sweeps the enormous canyon behind the climber into view, revealing depth that the still photo only hinted at. Third example, an eerie steaming crater. A gentle forward push action, whether at a low speed, slowly closes the distance toward the glowing green pool. The plume of steam keeps drifting and rising, so the scene feels alive rather than a static zoom. Fourth example is the same crater image with the same prompt, but the action is now WK. The only thing we changed was the camera command, and instead of just approaching, the camera now dives over the rim and tilts down into the pit. This shows that the action sequence, not just the prompt, is what directs the shot. Fifth example, deep inside a dark sinkhole. A pure tilt up, action I, cranes the view upward toward the pale ring of daylight far above. Rotational moves like this read as the most camera-like of all the actions. Sixth and final example, a silhouette at a cliff top at dusk. Pushing forward carries the viewer out over the layered mountain ridges toward the glowing orange horizon, holding the moody twilight color the whole way. One honest caveat. Forward motion tends to look like a person walking, with a gentle bob, rather than a smooth camera crane. That is because the model learned from gameplay and real-world walking footage. We measured it carefully. Lowering the speed helps a little, but video stabilization does not, because the motion is baked into the generation. For smoother results, the bidirectional diffusion variant is the most promising lever. So how do you actually get this running on a 24 gigabyte card? Here is the short version of the setup. The recipe is 5 steps. Pin Python and make a virtual environment. Install Torch first, using the QDA 12.4 wheels, before anything else. Install Flash Attention from a pre-built wheel, rather than letting it compile. Install the remaining requirements and pin the video library AV to version 12. And finally download the model weights into the shared cache. With that, a single inference command produces a 5-second clip. Fitting a 5 billion parameter model plus its decoder into 24 gigabytes is tight. The trick we patched in is to offload the diffusion transformer to the CPU just before the autoencoder decodes the full clip. During denoising, the transformer sits on the GPU. The moment decoding begins, it steps aside to make room and steps back for the next chunk. That single offload is what keeps the peak under 24 gigabytes. The released code did not run out of the box. Here are the real problems we hit and exactly how each was solved. 4 problems stand out. Flash attention refused to build, so we used a pre-built wheel. The checkpoint failed to load with a shape mismatch because a config flag changed the attention size. Setting PRoPE to true fixed it. The tokenizer had no padding token under the newest transformers, so we set one explicitly. And generation ran out of memory while decoding, which the transformer offload and a pinned video library resolved. Only the first of these is documented upstream. Our honest verdict: the image fidelity is genuinely beautiful, and it really does run on a 4090. The weaknesses are that motion feels embodied rather than cinematic, and longer takes need more memory than this card has. The release is alpha quality, so expect to read the code rather than only the readme for short atmospheric exploration clips. It is a delight. That is DreamXWorld running on a single consumer GPU. All the links to the model, the weights, and the technical report are on screen. Thanks for watching this hands-on walkthrough, generated end-to-end on a local 4090.